Morning student. Today I will discuss about some numerical problems related to surface area of the curve, revolution about x-axis, y-axis and parallel to the lines. In the previous lecture we will discuss some numerical problems, some simple problems related to surface area, but now here we discuss some critical types of problem that are related to surface area. Now taking first problem, find the surface area of the solid that generated by the revolution of the curve y square equal to 4x, x value from less than equal to 3a greater than equal to 0 about x-axis. Then first of all we see that given that the curve, given that y square equal to 4ax, that is that curve. Y square equal to 4ax, that is the curve of initial lengths. Now we trace the curve. We trace the curve. Here x is less than equal to 3a greater than equal to 0. Now we trace the curve. Then we simplify x dash y dash given curve is the parabola which is symmetry about x-axis. Given curve is parabola y square equal to 4ax and x equal to 0 to x equal to 3a, x equal to 3a line, this point will be 3a 0. This curve is rotated about the line x-axis. Then the curve is rotated about the x-axis. Then the line parallel to y-axis will be the radius of the circle that generated by the revolution of the curve, which is parallel to y-axis. Then we take the radius of the circle that generated by the revolution will be 1. Then the surface area is equal to integral 0 to 3a 2 pi y ds upon ds. This can be written as ds by dx into dx. This can be written by this one. Here now ds can be calculated by using this formula by dy upon dy. Now ds upon dy. Now ds upon dy equal to under root 1 plus dy by dx whole square, then dy by dx. Now we differentiate, this implies 2y dy by dx equal to 4a. This implies dy by dx equal to 2a upon y. Now we substitute the value of dy by dx is therefore, the surface area is equal to integral 0 to 3a. Integral 0 to 3a, the surface area integral this curve is 0 to 3a. ds upon dy. Now here we take dx and it is also a dy dx and dx upon ds. This implies 2 pi 1. The value of y is under root 4ax into the value of ds by dx is under root 1 plus dy by dx. It means 4a square upon y square into dx. This implies can be an integral 0 to 3a This implies 2 pi under root 4ax, and the value of pi square will be 4ax. Then this can be written as under root 1 plus 4a square upon y square is 4ax into dx. Now we simplify. Then this surface integral s is equal to integral 0 to 3a 2 pi under root 4a into under root x, and the value of this after simplification will be under root x plus a upon x dx. This will be equal to integral 2 pi, it means 4 pi, under root 4 is 4 into under root a integral 0 to 3a root x will cancel out, and this can be written as x plus e raised to the power 1 by 2 dx. Now we integrate. Then the surface area as equal to 4 pi under root a. This implies x plus e raised to the power 3 by 2 divided by 3 by 2 and the limit 0 to 3. Then the surface area after this simplification will be 56, this can be written as 8 pi root a upon 3, put upper limit minus lower limit, this implies 4a raised to the power 3 by 2 minus a raised to the power 3 by 2, this implies the surface area is 56 pi a square upon 3. Now this is the required surface area of this curve when the curve is rotated about the x-axis will be 56 pi a square upon 3 in the total surface area of this curve. Now in this series we take second question, which is also related to the surface area. Now the second question is find the surface area. Second question, find the surface area of the curve r equal to a 1 plus cos theta, which is known as chordate. Find the surface area of the curve r equal to a within bracket 1 plus cos theta, which is known as chordate, about the initial line. That is the theta equal to 0. Find the surface area of this curve r equal to a in bracket 1 plus cos theta, which is known as chordate, about the initial line. Solution. Now the given equation r equal to a 1 plus cos theta is polar form. Now here we use the surface area, here we use the formula of surface area which are related to polar coordinates. Now given that equal to a 1 plus cos theta, which is chordate. Which is chordate, a special type of curve. Chordate. We trace the curve. We trace the curve because we have to find the limit of integration. So we trace the curve. That is the theta equal to 0 degree. Theta is equal to pi by 2. Theta is equal to pi, and theta is equal to 3 pi by 2. Now the equation of chordate has this shape like this. This is the chordate which has the symmetry about the initial line. Now in our question, the curve is rotated about the initial lines. Thus, when the curve is rotated about the initial line, it generates a circuit of radius which is parallel to the line theta is equal to pi by 2. Now, in the first quadrant, the theta varies from 0 to pi by 2, and the upper quadrant theta varies from 0 to pi. Then the surface area S equal integral 0 to pi 2 pi y into ds, and ds can be written in terms of theta. Now surface area S equal to integral 0 to pi 2 pi y and ds upon d theta into d theta, and the value of ds by d theta is S equal to integral 0 to pi 2 pi y into r square dr upon d theta whole square d theta. Now, which is the required formula that we are